This recording is about 4F, which is the last exercise of chapter 4. In 4E you looked at geometric sequences in terms of recurrence relations. Now we're going to look at them in terms of a rule for finding the nth term in a geometric sequence, which, if you remember, is a sequence which is created by multiplying or dividing by some ratio to get the next term. The rule for the nth term of a geometric sequence looks like this, where r is the common ratio as before. Tn is the first term a multiplied by the ratio raised to the power of n minus 1. What that means is, if you wanted to find the seventh term of a sequence, T7, you would get the first term a and you'd multiply that by the ratio r raised to the power of 7 minus 1, which is 6. I'm going to jump straight to the exercise as the best way of showing how to do these things that you can do with this relationship. And when I've finished, I would like you to go and actually do the whole exercise, some of which will have been done and some you'll have to do yourself. So the first question asks you just to look at a sequence of numbers, 12, 24, 48, and to give the value of the first term a, which in the first case will be 12. And the ratio you've got to get by, we've only got 3 terms, so you've got to make sure that 24 divided by 12 is 2, and make sure the other one is also 2, 48 divided by 24. And the second one here, a is 56. Always divide the term by the previous term, so r will be 28 divided by 56, which you should simplify as a half. And check that's also 14 divided by 28 is also a half. And the third one here, a is 1 and r is 10, fairly easy to see. On the next 3, you're not given a sequence of numbers, you're given a recurrence relation, as in 4e. In the first one, a, the first term will be given by the first number there, which is 3. And the ratio is the 4. That's all you have to do there. The ratio is 4, and that'll be, if you wanted the seventh term, you'd do 4 to the power of 6. So I'll leave you to do the others, give you a moment to recognize that in the next one, a is 8 and r is 7, and so on. Now here's the rule up here. Tn equals 8 times r to the power of n minus 1. So if you get 3 numbers, what you're going to write to give the rule is t and little n is going to be a, which in this case is 4. 4 times, now the ratio, 20 divided by 4 is 5, 100 divided by 20 is 5, so it's going to be 4 times 5 to the power of n minus 1. And that's all you have to do. So that 5 came from 20 divided by 4 equals 5. Next one, Tn again is 8 times 3 to the power of n minus 1. That's all you have to do to do that. Identify the ratio as 3. 24 divided by 8 equals 3. And make sure the other 2 pairs of terms also produce a ratio of 3, otherwise it's not geometric. Right, we've got a rule, let's use it. Find the 10th term in each of these geometric sequences. Well, the first one here, T10, which is the one that we want, is going to be 2 times, what's the ratio? 6 divided by 2 is 3. 3 to the power of 9, because 10 minus 1 is 9. If you are not sure how to get that on a calculator, you should find the x to the power of y button or some such equivalent and just do 2 times 3 raised to the power of 9. And this one, T10, is going to be 512 times, now what's the ratio? R is 256 over 512, which is 1 over 2. So you want 0.5 to the power of 9, because we want n minus 1. And again, check your answers in the back, make sure you know how to get that answer on a calculator. The next few questions in the exercise are similar, but this is the last one. I'd like you to make sure that you can do this, which is quite actually complicated. First of all, the question: generate and graph the first 5 terms of the geometric sequence defined by the recurrence relation. So this given as a recurrence relation. T1 is 10,000, Tn plus 1, 1.25 to the power of Tn. Now obviously A is 10,000 and R is 1.25. Remember, we're doing a recurrence relation here, not the formula. So, to graphing it for part A. Now, I did tell you this before, but to do sequences on a graphics calculator, press mode, sequence, or second function, list ops, 5 sequence, enter if that is easier for you. But either way, you want to, when you press the mode button, to make sure you've got sequence selected. And then press Y equals on your calculator to put the formula in. This is where it gets complicated. Y equals is up here, by the way. That one there. And you should have a screen like I've got on the left here. Now, when you press Y equals, you will see a screen that will need to be filled in like I've done here. Now, first notice that although we're given a recurrence relation, we actually have to convert that into the formula first of all. So by that I mean just write down somewhere that Tn equals 10,000 times 1.25 to the power of n minus 1, and that's what's going to have to go into the graphics calculator. So on the UN line, I've entered equals 1.25 times. Now that u, if you remember, that u is got by doing second function 7, which is in there. So second function 7 gives you the u. And then left bracket, and then n, which is in here, minus 1 close bracket. Now pause my presentation while you get that line into your graphics calculator. Then for the next line you want to put the minimum value is 10,000, or rather the first value. Alright, let's see what it's going to look like. To plot it, you'll probably need to use the window button. I don't think Zoom 9 will be very helpful. Now, notice what I did for the window. The nmin and nmax I've put as 1 to 25 in here. And I've also put that in xmin and xmax because that's the same thing. And ymin, now the first time I did it, I put 10,000 for the first value for y and 100,000. I was just guessing what the biggest value was. But that will give you enough to do the answer to the question here, which was graph the first 5 terms, which is what is here on the right. To get the numbers for Tn, you haven't got to work them out by hand, just go second function table, and that will bring up that sequence of numbers there, so you can plot them directly. So your 1,000 is there, 12,500 is there, and so on, 15,625, 19,531, and 24,414. And if you were doing that on paper, that's what you'd have to do. Before you start plotting points, make sure that your Tn goes high enough to cover those 5 points. To calculate the value of the 25th term in the sequence, the last thing I'm going to be looking at, just scroll down through the table. You will find you'll get to the 25th term, and it's going to look like that, which is quite a big number. That is 2.12 times 2.12 e6, which actually means times 10 to the power of 6, which makes it 2,120,000. So the 25th term is 2,120,000 to 3 decimal, or 3 significant figures anyway. It doesn't ask you in the book to plot the graph like I've done here, but in order to do that, you would have to set your Ymax value there to more than 2 million, so make it 2,500,000. And then you will get a pretty graph like that. Okay, that's everything about geometric sequences. Try to complete all the questions in the exercise 4F on page 133, preferably by leaving what I've been through for an hour and then going back and doing them all. Okay, chapter 5 next.